Hello everyone, welcome to our presentation on UpCycling. This study is collaboration between researchers from Seoul National University and SK Telecom. Our presentation will offer a concise overview focusing on the core concepts. For those interested in, please make a note of our poster session or you can refer our paper. Traditionally, vision-based object detection models require the collection and meticulous annotation of extensive 3D scene datasets. This process, while essential, poses certain challenges. First, there is a potential risk of exposing private information, and additionally, the massive volume of data demands significant labeling cost. To solve this problem, we proposed the semi-supervised learning with the identified data. This approach addresses not only the concern about labeling cost, but also those related to privacy leakage. As shown in the figure, if we utilize the feature data from the 3D model backbone, we can take advantage of reduced labeling cost, enhanced privacy measure, and optimized AV side computation overhead. For autonomous driving, the vehicles continuously perform the model's detection pipeline for newly observed 3D scenes. Each vehicle collects a new 3D scene's intermediate feature and detection results to the central server. This serves as the identified unlabeled training data. And here's a remarkable aspect. No additional computation is expended on the identification, because these features naturally emerge from processing within the 3D backbone network present in the detection pipeline. Now let's move on to the server-side method. Ground truth that does not overlap with the detection results is sampled to form hybrid pseudo-label set. By doing so, on one side, existing GT samples provide powerful supervision with having zero noise. Conversely, the pseudo-labels act as broadening our data spectrum. UpCycling performs semi-supervised learning with these data obtained at feature level and further strengthen the existing model performance. One of the questions in feature sharing is the resistance to an inversion attack. We conducted an inversion attack on the 3D backbone networks. Our focus was on three distinct convolutional layers, the first, third, and the fifth or last layers. Observing the figures, the restored point cloud from the first layer is noticeably akin to the original scene. But as we probed deeper into the third and fifth layers, the restoration outcomes diverged dramatically from the original. We also assess UpCycling's effectiveness across diverse scenarios, starting with domain adaptation. Here our method is trained using data that's labeled in the source domain and is then put to the test using unlabeled data from a different target domain. Moving on the partial label scenario, in this context, we are working with a singular domain but using a restricted set of labels. Against SOTA methods, UpCycling stands strong, often surpass them. Our results are promising. For a detailed analysis, please refer to our paper. Let's conclude the presentation. UpCycling is a novel semi-supervised learning method for 3D object detection models and improves model performance by gathering the identified unlabeled data from vehicles. To the best of our knowledge, no study has considered labeling cost, privacy, and edge computing resource in vehicles and overall system altogether. Through various experiments using multiple datasets, we verify superiority of UpCycling in partial label scenario as well as domain adaptation. Furthermore, we also confirmed effectiveness of feature-level GT sampling. Thank you for watching.